Did you have one in there?
No. I was recording that. You were poking the dots.
Thanks. Add a little humor to the videos.
Yep.
Okay, our learning target today was actually graphing exponential functions. Okay, so that's really what we're going to work on next. We're going to graph a couple of them here. I think I can fit 2 of them in the time that we have. It's going to be close. Okay, so we're going to graph a real basic one here. Y equals 2 raised to the x power. Okay, now you don't see an a value here, but what is the a value then? 1. Very good. My b value is 2. All right. Just because I'm going to go ahead and make a quick table of values. It's good practice. -2, -1, 0, 1, and 2. You can have your graphing calculators make this table of values for you. All right, not a big deal. You'll use your graphing calculator a lot probably when you're graphing these functions. Okay. We'll start down here. What's 2 raised to the positive 2 power? 4. So then what's 2 raised to the negative 2 power? 1/4. 2 to the positive 1 power? 2 to the negative 1 power. 1/2. Don't say negatives. They're not negatives, okay? You know, anytime you raise a number to a negative number, it's a fraction, okay? Fraction. And 2 to the 0th is 1, okay? So I'll go ahead and draw a quick little graph.
Beautiful stuff.
0, 1, 1, 2, 2, 4, -1/2, -2, 1/4. All right? So I got all these up here. I got these points plotted. What's going to continue happening to the graph as I move to the right? Get up fast, right? Increase really fast. 3 would be 8, 4 would be 16, 5 would be 32, and so on, right? Get real big real fast. How about as I go to the left? Get really small. What do you mean by really small?
Well, it'll flatten out, but it won't.
Flatten out close to 0, right? Okay, not really small as in negative small, right? Just really small as in positive numbers small.
You can't get to 0.
So it'll get really, really, really close to 0. Will it ever get to 0?
No.
Nope. Okay. Because even 2 raised to the negative 100 power is just simply the fraction 1 over 2 to the 100th power, which is a very, very, very tiny decimal. Okay, a tiny fraction. So your graph looks like this. So that'll be one thing you'll be asked to do, is to draw a graph of it. Use a graphing calculator to help you. Make a table of values mentally if you want. I don't care. Whatever works best for you. You'll probably use a graphing calculator as they get a little more complicated. Okay? Here are some properties that you'll need to be able to do, all right, as far as this graph is concerned, because that's our learning target. Be able to graph exponential functions and identify some key properties. Okay? First one, fairly simple one. Y-intercept. What is my y-intercept in this case? Give me a coordinate, please.
0, 1.
0, 1. 1. That's funny. That matches the what value? The a value. Okay? So 0, 1 is my y-intercept. Another thing you'll have to do is domain and range. What's the domain of this function? What are the x values that this graph touches? What are the x values you can plug in for x and expect to get an answer for y?
Negative infinity, positive infinity.
Everything? Does the graph go left forever? Does it go right forever? Does it touch every x value in between? X values? Absolutely. Domain, everything. Negative infinity to positive infinity. Use interval notation as we did last chapter. So my domain is negative infinity to positive infinity. Range.
Greater than 0 to infinity.
Nice job. 0 to infinity. Does the graph ever touch negative y values?
No.
In fact, does it ever even touch 0?
No.
Does it get really close to 0?
Yes.
Okay? So what we do for range then is we say parentheses 0, infinity. Okay? It touches every y value from 0 to infinity, but not including 0. If it included 0, we would have made a what?
Bracket.
Square bracket. Yep, very good. Alright? So domain, range, y-intercept, and then one last thing here. This will be new for you. Okay? This next thing's going to be new. I'm going to introduce you to a new vocabulary word as an asymptote. Okay? An asymptote. An asymptote is an imaginary line that a graph gets really, really close to but never touches. An asymptote is an imaginary line that the graph gets really, really close to but never touches. That's my definition, not a great mathematical definition. I'm sure there's a better one if you look it up or something, but I think this makes sense to most people. Okay? An asymptote is kind of an imaginary line that the graph gets really close to but it never touches. So if you think about the graph that we just drew, is there a value, some sort of value that the graph gets really, really close to but never quite gets there? Zero. Yep. So what you will also be asked to do, has everybody got this definition down? See a couple of you writing still. Let me know when you're ready.
So is there a symbol for it?
What all you're going to do is you are actually, because there is, you're going to kind of draw this imaginary line, okay? We're going to put a dashed horizontal line at 0. That's how we draw asymptotes when we draw graphs. We kind of put the imaginary line, whether it's a vertical asymptote or in this case it's a horizontal asymptote, okay? So my horizontal asymptote is the line y equals 0. That is something that you will have to be including on your graphs each time you graph one of these exponential functions. Okay? You have a horizontal asymptote at y equals 0. Okay? That horizontal line, y equals 0, that is a line that this graph gets really, really, really close to but never actually hits it. Okay? The horizontal asymptote, HA is what you'll see me write, okay? The horizontal asymptote is y equals 0 in this case.
Well, can you get like a diagonal?
Okay? You can. We don't really in Algebra 2 mess with what's called slant asymptotes. In fact, we don't even mess with them too much in advanced math. We might talk about them briefly, but most of our asymptotes are going to be horizontal asymptotes or vertical asymptotes. Okay?
Is there ever be a way to touch the 0 on this, or is it?
Nathan's thinking ahead. He goes, well, I'm guessing he's thinking, well, aren't the asymptotes always going to be at 0? Yes, unless I put like -5 back here behind the function at the tail end, because that's going to shift everything down 5 units. So then the graph could actually touch. But if it's always y equals a times b raised to the x power, y equals 0 will always be your horizontal asymptote. That will always be your domain. That will always be your range, okay? So a lot of these things will repeat themselves unless I start throwing +4 back here, -2 back here. Then things change up just a little bit, okay? How's my time?
8.
8, okay? I'm going to just put it all in one here, okay? Okay. The next one here, follow along real quick, then I'll give you some time to write down what you need to, but I'll close out the video, okay? This one, definitely more complicated function, y equals 5 times 1/2 raised to the x power -2. What's my a value? 5. What's my b value? 1/2, okay? And then I got a -2 at the tail end of it. A couple things here, okay? The last function we graphed. Do you think this is exponential growth or exponential decay?
Growth.
Growth. Why?
Because it goes up.
It goes up. Numbers are getting bigger. What number are you multiplying by over and over and over again in this one? 2. Yes, it's positive, but 2, because I'm going to go to the next one here in just a second, okay? We're multiplying by 2 over and over and over again. When you multiply something by 2 over and over and over again, what happens? It gets bigger, right? Okay? Check out this one. What number are we multiplying by over and over and over again? 1/2. What's happening? It's getting smaller. Okay? Yep. So where's the cutoff? When do the numbers get bigger when you're multiplying? When do numbers get smaller when you're multiplying? 1, right? If you multiply something by 1.1, what's it going to do? Get bigger. If you multiply something by 0.9 over and over and over again, what's it going to do? gets smaller. Any number between 0 and 1. If you multiply by a number between 0 and 1, you're going to decrease. You multiply by a number bigger than 1, you're going to increase. Steve?
My boss is calling me. Can I take this really fast?
Go out in the hall. Okay? So, I could have told you, without looking at this graph, I could have told you that this is going to be exponential decay. Why? The b-value is 1/2, right? The b-value is 1/2. Anytime the b-value is between 0 and 1, you're going to have decay. Alright? Now, on a complicated function like this, I would probably go to my graphing calculator. Alright? I would type this into my graphing calculator, pull the table of values off the graphing calculator. That's what we did in the other class when we had a little more time yesterday. Okay? So we did that. We plotted some points. -1, 8, 0, 3, 1, 1/2, 2, -0.75, 3, -1 point something, 4 was -1 point something, 5 was -1 point something, 6 was -1 point something, 7 was -1 point something, and these 1 point somethings kept getting closer and closer and closer to what does it look like? -2, but it never actually gets to -2, but it gets really close to -2. Therefore, what do you have at -2? Horizontal asymptote. Okay? Horizontal asymptote, which should make some sense too, because remember how I said they would always be at y equals 0 unless I put a number back there? Well, what does a -2 do to any graph? Shifts it down 2 units. So if your horizontal asymptote was at y equals 0 and you shifted it down 2 units, now your horizontal asymptote's at y equals -2. Okay? So I drew my horizontal asymptote at y equals -2, labeled it right here. Okay? My y-intercept was 3. You should notice how it gets to 3. If I didn't have the -2 back here, what would be my y-intercept? If I didn't have a -2 back here, what would be my y-intercept? What's the a value? 5. What's the -2 do to everything? Drops it down 2. So that's why my y-intercept now is at 0, 3. Okay? Domain, still the same, right? Goes left forever, goes right forever. Range, down to up, down to up. What y values does it touch? Everything above where? -2, so my range is -2 to infinity. Okay? If you are capable of graphing an exponential function, writing its domain, writing its range, writing its y-intercept, writing its horizontal asymptote, you're off to a pretty good start. Okay? And then I will go ahead and tell you guys on the test, there is a question about how you know whether something is exponential growth or decay by just looking at the function. And how do you know?
If
The
it's a
b
fraction.
value. If the b value is bigger than 1, it's growth. If the b value is between 0 and 1, it's decay. You need to know that. Okay, there's a little writing question about that on the test, so jot that down if you need to in your notes. Put it into memory. Go ahead, Nathan.
Is there any way the b values get negative?
The b values could be negative numbers. Those aren't realistic as far as necessarily changing things to a story problem or relating it to anything. You're going to work with mostly positive ones, but yeah, that doesn't really make an exponential function, to be completely honest with you. It's kind of a weird graph. So you're going to work with positive. You might work with negative a values. I could see that. That just means the graph is flipped, basically. Okay? You guys can pause it if you want.